Okay, this is the first video regarding statistics. We're going to go over descriptive statistics and how to visualize them. We'll also take advantage of a lot of the procedures that are within packages. So we'll use the command with to minimize the amount of typing that we have to put in. Let's get started. Because we'll be using so many procedures from the statistics package, instead of writing out statistics associated with each procedure, I'm going to use the with command to load all the procedures at once. If you notice, that is a slew of procedures. Normally what I prefer to do is when I use this with command, I end it with a colon, and that starts our process. Okay, at this point, let's create some random numbers using our random tools. We'll use a normal distribution and create 24 points. This will allow us to measure the mean, standard deviation, and the standard error of the mean, which are usually the three most important descriptive statistics values that we look for in any data. So here's some of our data. Maple makes it very easy to be able to calculate the types of values that you're looking for. For example, if you want the mean of a value, you just simply say, I want the mean of the data. Notice our data is in the form of a list, and it quickly calculates it out. You want the standard deviation? Write out the word standard deviation. Of what? The data. You want the standard error of the mean of the data? Sure. Of the mean of the data. It will also calculate the standard error of the standard deviation. You want the median? Not a problem. It will find the median value. Want to know how many points are in there, or just count them? Hey, how many are 62s? How many are 61s? That means tally. In this case, it turns out of 63, there are 2 of them. Of 62, there are 6 of them, etc. But maybe one of the more useful tasks is to just get a summary. Data, summary of data. All right, what we're going to do now is we're going to visualize our data, but we're going to import the data using the Excel tools package. So again, I'm going to load the statistics package using the with command. Here is what it looks like in Excel. Then I'm going to use the Excel tools input. The spreadsheet is in the same directory where I'm keeping this particular worksheet. So I'll use the import. And then once I have this data, I'm going to refer to everything in the first column, every row in the first column as X, and every row in the second column as Y. So let's start. Hit enter, hit enter. Those are the data points. And then as you can see, we've stored X and Y. Now I'm in a position that I can make a scatter plot. X, Y. What symbol shall I use? How about a solid circle? How big should this symbol be? Let's make it 20. And as you can see, there are the points along the X direction, there are the points along the Y direction. Of course, you could also just plot the data itself, and it will take that matrix and assume the first column is X and the second column is Y. Either method works with the scatter plot. And now we end with a more sophisticated example of visualization. Again, we're going to load the statistics package. In addition, we're going to take some data using a Maxwell distribution. And now we're going to make a histogram of our data. And if you can see, the histogram shows essentially how frequent a particular set of numbers appeared, in this case between 0 and 5. If you want, you can actually do it by just frequency scale in terms of absolute rather than as a fraction, in which case it looks something like this. Using the fact that we used 1,000 points, it's not surprising we got values over 300. Now, let's go back and redo this histogram, not by the absolute scale, but rather by the frequency or probability scale, and draw it in lovely salmon color. We're only plotting between 0 and 5. Okay. With this, we can combine it with the function that tells us the shape of this distribution. This is the Maxwell function. We create the function itself, and then finally, using the display procedure within the plots package, we can display both the histogram and the Maxwell function distribution. Because we used many procedures from packages, sometimes it's advantageous to load all those procedures at once with the with command, and then sometimes it's more useful and more descriptive to use the : to refer to a particular procedure from a package.